All right, great. It is just a minute past. Sorry for the slight delay there, everyone. We're going to get started now. For those that don't know who I am, my name is Steve Teresi. I'm the Director of Training and Technical Services at JL Audio. I'm located in Southern Florida, just a few miles north of where our main headquarters is located. I have with me today from the greater Pittsburgh, Pennsylvania area, Mr. Kevin Ferry. Please say hello, Kevin.
Hello, everybody.
Fantastic. And we also have Mr. Rob Haynes joining us from Southern California. Please, Rob, say hello.
Hello, everyone.
Yeah, see, I didn't give you the bait on that one. So fantastic. Well, we have a great session put together for you today talking about our subwoofer technologies. A couple of things, some housekeeping notes. We are streaming live here on WebEx, and we have a group of people here. There's a chat function that Kevin and I will be monitoring. We also have a live session going on Facebook Live. And anyone that's joining us on Facebook, there's going to be a slight delay between what we're presenting and what you actually see. So on occasion, if we ask any questions of the audience and you want to participate, you can put comments in the chat off on the side and we'll get to that. Just know that you're a few seconds behind us. Everyone on WebEx, it's a bit faster. We have a chat function there as well. If you don't see it, if you move your cursor across your screen, you'll see a little menu bar pop up and there's a little chat-like bubble. Click on that, you'll see the chat on the side. And just make sure you share your comments with at least Kevin or myself. In this case, I'm going to say Kevin. I'm having some technical issues here. So we'll do our best to keep an eye on both the chat here in WebEx as well as on Facebook. If you have a webcam and you're on WebEx, keep that on. We got a couple of people that are not shy. We appreciate that. What else, guys? Did I forget anything?
I think that's it.
That's it. Okay, so what we're going to do now is I'm going to pass it over to Rob, and Rob's going to be our lead presenter. He will not be able to see your comments, so be nice. But as soon as he's done sharing his screen after the end of the session, we'll open it up for some additional questions and answers. If you do ask a question that you want to get to Rob, just let us know. We'll do our best to get it to him, make sure it's going to feather in with the presentation he's got planned for you. So go ahead, Rob. Take it away.
All right. Thanks, Steve. Let me actually first get my screen share started here. And all right, are we good? You guys see my screen?
We do, and your cursor's not on it. That's a beautiful thing.
Yes, yeah,
There it is.
Oh, there it goes.
All right. Thanks for joining us today, everyone. This is an exciting training for me. It's actually going to be the first in a series of trainings that we're developing. And what we're going to do today is really just do an overview of the key technologies that are found in JL Audio subwoofers. And this is the precursor, if you will, to an entire series of trainings on each family of subwoofers. So to stay with our normal time constraints of around 35 to 45 minutes, these are going to be overviews of the technologies. We're not going to really break them down in ways that we will later on when we get into the specific trainings on W7 or W6V3, W3V3s. So if I don't go into as much detail as maybe you're hoping for, ask a question. But we want to be respectful to your time, and we've got a bunch more trainings coming out where this stuff will all feather into those specific families of drivers that you guys are all working with and have known for a long time. So what we're going to do today, we're going to talk a little bit first about our engineering and why we have so many technologies in our subwoofer lineup. We're then going to go through those technologies, and then we'll have a quick Q&A at the end. And I always love the Q&As because we tend to get off topic, and there's usually some good stuff that comes up after the fact. So with that said, let's get going. And, really the main reason we have all of these technologies found in our subwoofer family, it's because of this man right here, Lucio Proni. He's the L from JL Audio. He's our founder. He's still our chief speaker designer. And him and his team that he's put together really do a phenomenal job of thinking outside of the box and coming up with technologies that really are game-changing. Steve, Kevin, and I were joking earlier, some of these technologies we're going to talk about, they date back decades. And, our slogan of being ahead of the curve, there was a reason for that, because all of these technologies, the design of our drivers 15, 20, 30 years ago, it all was ahead of the curve. It was revolutionary, which is why a lot of these are patents. And some of them have been around so long, the patents have actually run out. And I think a patent's 20 plus years or something like that. So some of these technologies, man, they go back to, way before I was in car audio. So it's really cool to see how Lucio and his team in South Florida, from the initial design of the speakers to all the different testing of components, of materials, feathering our technologies into all of that. That really, for me, is what makes a JL Audio speaker so special. And
Hey, Rob?
yeah, Steve.
So you knew I was going to do it. I interrupt all the time. So you're talking about the patents and how long they last. And I think it's sort of funny, and maybe it's a bit insightful, that some of the patents that we actually applied for, we didn't bring those products to market for several years after. And it's not because we were lazy or still trying to figure it out. We had to figure it out. But the tooling, a lot of tooling was not available. We couldn't get the parts actually made. We designed parts that tool companies couldn't actually reproduce. So we actually had to go back and redevelop certain technologies, not change them, but actually develop the tools so that we could actually build them. One of the technologies that Rob's going to talk about is the concentric tube. That's a great example of how the tooling back then was not available, and we had to help create it. And that led to a several-year span between when we came up with the idea and when you actually saw the product. And that's some of the insight that goes into why it takes so long sometimes for us. So sorry about that, Rob.
Yeah, no, it's all, really good points. And, for me, this stuff's important, and I think it's important for our retail partners, and it's also important for the consumers to understand. I remember when I worked in retail, I had a customer ask me one time why a 10W3V3 at 250 watts RMS was $250, when brand X at 500 watts was $200. So it's twice the power. Clearly, it's a better woofer. So why does the JL Audio cost more? And, I didn't really have an answer back then, but now I can say, oh, there's 4 patented technologies in the suspension alone that make it bulletproof when you use it right. It's designed in the US, built in the United States. I mean, these are important factors. And I see all the time, oh, JL Audio is expensive. Oh, you know what? There's a reason for it. You're paying for a premium brand. You're paying for technologies that give you not just a phenomenal sounding speaker, but really do a fantastic job of improving the reliability in key areas which are the most prone for failure, whether it's heat related or mechanical related. So this is all very important stuff that really, it's the DNA of our company. It's building not just great sounding stuff, but stuff that has to last, because that's what our customers want. They don't come into our shops and say, I want to buy a subwoofer that's not going to break. So we keep that all in mind when we design this stuff. Another key factor for all of our technologies is the fact that a lot of our our subwoofers outside of W1V3 and the W0V3 are all built here in the United States. All of our thin woofers and then W3V3 all the way up to the W7 are built in our South Florida facility, which also then allows us to keep those patents a little closer to heart. So we're not then letting factories, see our tips and tricks. We have a ton of patents. Some of them you might not even see in the product. So there's a lot of stuff that goes on to that. And again, our US-based manufacturing is one way we're able to keep those patents or keep some of our technologies, somewhat on the down low and not let it out to people who could then share it to competitors or other companies. And, it's really cool to see from start to finish how it all kind of comes together, from the engineering in Florida to the testing, and then building our subwoofers in our South Florida facility as well. So with that said, I think we're ready now to start talking about some of these key technologies. And I'd say probably one of the most important, if not the most important technology we've come out with throughout the years is DMA, which stands for our dynamic motor analysis. And this is a very important technology for us that first came about when we were developing the W7. And the idea was to really have a dynamic analysis, hence the name, of what a speaker's motor is capable of doing. And there are other ways to test motors or to provide analysis to motors, but typically they require either low power or a stationary motor. The idea with dynamic motor analysis is as power changes, the magnetic field in the motor and the speaker is going to change. As the coil moves through its gap, that changes how the motor behaves. So with our dynamic motor analysis, we're able to not just look at it as a standing still speaker, how it's going to behave, but we can predict how it's going to behave under different power applications, how it's going to behave as the coil moves up and down through the motor assembly. and really allows us to build a truly linear motor by understanding how it's behaving at these different performance peaks. And when you know how the motor is going to behave right off the bat, it really makes it a lot easier to design everything else around it. If we can predict the motor's behavior, we have a better insight into how we need to work on the suspension. Instead of trying to do all of these things and how's this going to work, we start with a very solid base. The motor, I guess, is a pretty good base on a speaker.
Solid base, Rob. Get it? Base. That's a great image you have on the screen. It brings back memories. For those that don't know, that's a graph from our original W7 training that took place some time ago, we'll just say. And just real quick to expand on what Rob has shared with us, the black line that you see is what would be considered a stationary coil measurement, the motor measurement. And what you see in the dotted lines and the solid lines are forward or rearward motion at different power levels. Ideally, that should be a flat line across the middle of your screen and never change. But the reality is it's always changing. What you're looking for then to be as wide as you possibly can and taper off and be the same on the outward stroke as you are on the inward stroke. And you see on this particular driver, which happens to be the original 12W7, it's really, really good, both in the outward and inward motion at power levels as small as 0 watts, of course, and as high as 1,000 watts. Prior to the design of this technology, this DMA, the only way we could get this type of result was to build it and try it, then modify it, build it and try it, then modify it. DMA allowed us predictive behavior before we actually had to go to assembly. And as you notice along the bottom of your screen, this technology is now used in every single subwoofer that we make and every single component coaxial. Every speaker we do, we take advantage of knowing ahead of time how well the speaker is going to behave across the board at all power levels. This was revolutionary back in the day, and now it's become a core component of everything that we do. So this cannot be overstated how important DMA is to the success of general audio.
Yeah, without I just love the fact that, like you said, Steve, everything from a W7 down to a C1, all of our marine components, our home drivers, everything uses a DMA optimized motor. One other thing I want to bring up real quick that you guys are going to see on the slides, on the bottom of these slides, we're going to have the logo for the technology and then the logos for all the subwoofers that use it. So since all of our subwoofers use DMA, they're all black. You'll see on some of the upcoming slides, they'll kind of dissolve away if they don't use that technology. So that's what that is on the bottom. But a very important technology, not just for the W7, but as Steve said, it's filtered down to every single jail audio speaker made ever since. Keeping on the W7, another key technology we had developed is called the W cone. And this is a really cool technology. And I love when we go on tours, there's an area where the pre-assembled cone and surround are, where they actually attach the dust cap. And this is actually a technology you don't normally see because the dust cap hides it. So when I'm on a tour, I always like to show the cone assembly because you can actually see what the W cone is all about. When Lucio and the team was working on the W7 originally, they looked at all sorts of different materials. Obviously polypropylene, which is what we ended up with. We looked at other exotic materials. And when you have a high excursion woofer like a W7, it's going to move a lot. And that's a lot of torque and a lot of pressure on the cone assembly of the driver. And that's why you want a cone that's rigid. We want that stiffness so it can handle that. But it also has to be light. We want to minimize the amount of mass. So it's easier for the motor to move that speaker in and out so we can push more air and we can get louder. What Lucio was able to do and the team was by designing the W cone. So if you cut a W7 in half, the cone assembly actually looks like a W. And that's kind of neat. So by strategically bracing not just the sides, but the center, and then having the dust cap perfectly sit on the edges and the middle of the cone, it's provided an extremely lightweight, low mass, rigid cone assembly. And if you actually have ever held a W7 cone assembly with the dust cap on, it's as light as a piece of paper and there is no flex to it. It is ridiculously rigid due to this, almost architectural design to stiffen up the center. And, you know, one thing that I think that's kind of cool about the W cone with polypropylene, at least when the W7 was coming out, the W cone with polypropylene was 32% lighter than the average 12-inch aluminum cone and 7% lighter than the average titanium cone back then. So by using this material with this, you know, architectural,
it didn't dent like those other materials did. Something
yes,
we just saw a lot of.
Yeah, man. I know all about that. I had when I had my shop back in the day, we had some aluminum subwoofers on display. And when they're moving, everyone always had to put their finger next to it, and they would dent the cone on their knuckles. So you don't have that problem. But really, you have a ridiculously rigid, lightweight cone assembly, and it's all because of the geometry kind of in the center that you don't get to see. So really cool technology found on the W7 series. Also found on the W7 series is the overall surround. Again, W7 is designed to be a high excursion woofer. That's how we can play low frequencies really well, just as we can the higher frequencies. No matter what you throw at it, it's pretty much capable of doing it because of the surround. And large overall, you know, big surrounds are an important part when it comes to a high excursion woofer design. That's what helps the cone move as much as it needs to. But the problem with a typical oversized surround is you lose the piston area now. You're losing the dust cap and cone area on the top of the speaker because the surround's taking more space. So what Lucio and the team was able to come up with was, by extending the surround to the outer frame of the speaker, we can get that large surround that's needed for maximum excursion capabilities, but without losing any piston area that would compromise the overall output of the driver. And I remember when the W7s first came out, people scratching their heads like, how the heck do you mount this thing? Where's the mounting flange? But by hiding all
sending out pictures of us holding liquid nail, like a tube of liquid nails, holding it next to it and say, hey, it's the mounting technique.
Glue it around the edge to the box. But by extending the surround to the outer frame, we can get all of the excursion out of the driver that's needed without losing any output by freeing up the essentially the piston area to move more air. So this is again, back in we see this kind of stuff now, but in 2000, you know, actually this 2001, I guess, is when you can say the W7 came out, but there was years and years and years and years of development prior to that. This goes back to the mid 90s, and this was revolutionary back then to come up with these ideas to maximize, you know, excursion and you know, not compromise the output. So that's a very key technology for the W7's overall performance. Now we're going to get into some of the cool cooling technologies.
Cool tooling?
Cool cooling technologies. I know, I love my bad jokes. What can I say? But again, these are some of the key technologies that really come into play for the reliability factor, especially when you get into large, powerful speakers. There's going to be a lot of heat generated by the voice coil. We're sending lots of power to it. So we need to make sure we can do whatever we can to help cool things. And the radially cross drill pull piece was a really unique way to do that. Instead of a normal pull piece, so on the back of the subwoofer, you'll have a hole right on the bottom of the magnet, and then air can channel through it, and it would typically just go through the top into the top of the coil former, and then it'll kind of move around. But on our radially cross drill pull piece, we actually shrunk the top hole of the pull piece and have strategically placed machine holes around the outer edge. And what's neat about that is, as the woofer's moving, it's bringing the air into the pull piece, but because the top has been shrunk down and we have the side holes, it creates this high velocity airflow that forces cooler air onto the inside part of the coil former that doesn't normally get cool air, and it also removes that ridiculously hot air that would normally be trapped in there. So
right, it's kind of neat. Sorry, Rob.
Yeah, no.
I love this. It's really bringing back memories. So a typical pull piece is intended to move air across the inside of the metal part that's close to the voice coil. Voice coil gets hot, it gets the metal next to it hot. Cooling off the metal means it could take more heat from the voice coil. That's a really cool thing to do. But our engineers actually developed a way to make it even better. So in addition to cooling the metal itself, it's now forcing air directly onto the coil. And there's another technology Rob will talk about in a moment that's also doing the same thing from the other side of it. So instead of just cooling the metal, it's actually cooling the thing that's making the metal hot in the first place. It's a dramatic improvement. And it's not just to prevent the voice coil from getting too hot and potentially failing. It's also designed to improve the performance of the speaker by reducing a phenomenon known as power compression. As a coil gets hot, its behavior changes as well. So the sound characteristics of the driver will change at high power versus low power, or I should say at high heat versus low heat. By keeping the heat envelope more consistent, you get a better performing product over a larger operation envelope. So there's a lot that goes into this cool technology, and it's not just reduction of failures. It's truly an improvement in performance as well.
Yeah, so this was developed for the W7, which is why it's the only logo that's dark on there. But it actually first appeared on the 15W3 and 18W3s. And this is a picture of Kirk, one of our older engineers, working with the drilled pull piece from a original 15W3 model. So again, shows you how long this technology has been part of the JL family. And again, like Steve said, it's not just for the reliability aspect, but it helps with the overall performance of the driver as well. When paired with our elevated frame cooling, these two technologies are very key to the success of a driver. And I always think it's cool when I go through our technologies that the vast majority of them really are, reliability related. We've seen where failures occur. We see where heat causes loss of performance, and really put a lot of work into the cooling circuits to make sure we're not compromising or losing performance, and that we can also send extra power if needed through those coils. And one of the key things with elevated frame cooling is one of the original ways to do this essentially was to have holes drilled along the frame underneath the spider. And that would allow some air to get in, but it really wasn't high velocity air. By essentially raising the speaker's frame from the motor with some conveniently strategically designed stands, I guess you can say, we've created channels for air to flow across the top plate. And when the speaker's moving, that pumping action of the spider, it pulls that cool air into this high velocity tunnel, forcing that cold air across the top plate of the motor onto the coil, where it then can cool all of that down. And again, when you pair that up with the radio cross-drilled piece on the W7, you can really see how we can manage high heat applications and really do a good job of cooling them down, providing fresh air, and also releasing that hot air that could further warm up materials and cause power compression and other issues, as Steve's talked about. So
speaking of hot air, I have more to add. The actual size of that aperture is very carefully crafted as well. As Rob said, it's about the velocity of the air, but it also helps compress the air. And if you're familiar with air conditioning, there's a compressor involved, and it compresses air as well. By compressing it, you're making it cooler. And ultimately, that is part of the design of this, is that we're actually trying to create somewhat of a compressed air factor to keep. It's not just ambient air temperature, it's cooler than ambient air temperature by fitting through that relatively narrow opening. So there's a delicate balancing act on each one of the designs that use this, which is a lot of them, as you see across the bottom of your screen, of keeping that aperture small enough to have the compressed air effect of cooling, but large enough that it doesn't cause issues with noise. You don't want chuffing noises and things of that nature, because that would then affect performance sonically, and you don't want that. And obviously the tapering, everything that Rob talked about the way the contact points are all done, is all very carefully crafted. We've seen competitive product that have openings, but those openings tend to be much larger. The thought being that there's more airflow, but there's an actual backside of that it's not compressed and it's not higher velocity. And all of that is playing very carefully into the patents that we've received on our elevated frame cooling.
One other cool technology to help keep things cool is the P-VAC. This first came out on the W6 V3, but is again a technology that predates it. This is a older technology Lucio and the guys have been working on, but it didn't make its appearance until the W6 V3 family came out. And this is a different take on pole piece cooling. So actually, I have a pretty cool image here I'll bring up. Here's a cutaway line art view of a W6V3. And in the center there, you can see that kind of bullet-shaped device. That's the P-VAC. And what that does is as the speaker's moving up and down, again, we can pull air through the pole piece. But unlike the W7's pole piece where it's cross-drilled, this actually kind of pulls the air in between the pole piece and the motor. And again, forces cool air onto the inner portion of the voice coil former to again help reduce heat there, but also reduce heat on the metal surrounding the coil and motor assembly as well. And on top of that, you can also see how it pairs with the elevated frame cooling and how that cool air comes across the top plate right onto that voice coil former. So both sides of the coil, which is really where all that heat's going to be, since that's where the voltage is coming in, we're tackling it from both sides to remove that heat and help keep things cool. And this is a really cool piece, no pun intended, on the W6V3s, and a different take on getting air to those inner portions of the speaker without adding noises or compromising any of the performance. This actually
allowed us to also, for a second, Rob.
Yeah.
Okay, all right, cool. So there's a key thing here. One, that air channel, again, is very carefully controlled and is very narrow for that compressed air effect. And you can see how similar the elevated frame gap is to the gap between the P-VAC and the actual inner wall of the pole piece itself. But there's a subtlety that's shown here that'll come up again in a few moments when Rob talks about another one of our cool technologies. The inner entry and exit channel for the P-VAC that's pointing in and then up from the inside of the voice coil is blowing on a part of the coil that normally has no benefit of cooling. Normally the speaker has metal parts around it like the pole piece or the top plate, and those are going to help act as a heat sink to pull heat away from the coil. But the top part of the coil literally is hanging out in space. So using P-VAC technology, we're putting airflow around an area of the coil that's normally going to generate a lot of heat with no benefit of nearby metal to act as a heat sink. So this really solves another issue that Rob's going to talk about when he gets to another technology about the top burn of a voice coil. Happens very, very often. And this type of failure, if you're a consumer or a retailer that's dealt with failures, if you get a brand new speaker and you dump a bunch of power into it and you play it really loud and all of a sudden it breaks, it's like, oh my God, this thing's horrible. It broke so fast. What happened there is a buildup of heat in an area that couldn't get rid of it fast enough. And it's usually going to be the top of the coil. Companies like ours and any other manufacturer, what we'd like to see, if we're going to see a failure, we want to cut open a speaker and see the entire voice coil completely charred. That means that the customer played it for a really long time and built up a ton of heat across a huge span of metal over a period of time that was probably hours upon hours, at which point finally it said, this is too much and I can't handle it anymore. We don't want that failure to happen in the first 15 minutes of them playing the product. Technologies like this and others that Rob will share really help improve those rapid failures due to buildup of heat without a cooling circuit there. P-VAC did a really good job of that, even more effective than some of the other technologies. But again, as we develop, we learn and we start implementing it on different products, which is why this didn't make it on a W7, oddly enough. The radial drill did. And all of those, as Rob has already mentioned, all these technologies that showed up on the highest level did make some type of an appearance in earlier products. We just didn't make as big of a deal about it.
We got a pretty good question on Facebook that somebody asked is this why you see burns on the tops of voice coils from other subwoofers?
I think like Steve said, if you don't have consistent heat across the coil, if it's only in one particular spot, if it's on the top part of the coil, there's a good chance that's probably what it's from. There's an excess amount of heat buildup there because that top portion, even with cooling circuits, it's not normally in the area where that cool air is going to be flowing.
At risk of making you run long, Rob, I have an analogy that I used to use in the training for some of these technologies, and it'll be helpful. You'll save time later when you talk about the VRC. The VRC uses a similar type of cooling circuit. So imagine if you took your hand and you took a cigarette lighter. You shouldn't smoke, it's bad for you. But if you did and you had a lighter and you put the lighter near your hand and left it there, you get a large amount of heat buildup and burn your hand very quickly. But now imagine taking that lighter and moving it back and forth at the same distance away from your hand. You could probably keep that lighter there a whole lot longer and your whole hand is now getting hotter, but it's taking a lot longer before you get to the point where you have to pull your hand away in pain. You're spreading the heat out over a larger area. The failures, like the question on Facebook brought up, is if that heat's allowed to build up in a specific area without the chance of dissipation, you will wind up with a failure way too quickly, much like the lighter would burn you quick if the heat built up in one spot. So all of this stuff is taken from the mindset of how can we spread this heat out over a larger area to allow for a longer play time before we get into any trouble. And of course, the reliability is a big part of that, but the performance is as well. Coil changes behavior as it gets hot. So there's a whole bunch of things going into this. It's not just a cool technology, it's a performance one as well.
Yeah. Awesome. Thank you, Steve. All right, let's get off the cool cooling stuff and move on to something else. Another key technology found in all of our subwoofers other than TW5 and the W0V3 is our engineered lead wire systems. And this is a way to manage the lead wires, the tensils, if you will, coming from the terminal to where they attach to the voice coil itself. Now, if you see on this side image of the W3V3, you can see that our lead wires have a nice arc to them. And this is, again, all strategically done. Instead of just putting in, a lead wire and just slapping it here and gluing it here, there's a lot of thought that goes into the management of it. We want to be able to have a lot of excursion capabilities. And remember, this metal. So it's not going to have the flexibility like the spider when the speaker's moving in and out. And if we don't have the right amount of length or angle on the lead wire, when we start to move and we're maybe driving the speaker a little too hard, we can rip and tear or stop the excursion because the lead wire doesn't have the stretch or give. You can see fatigue. You can have jump roping, if you will, of the lead wires, which then creates noise in the speaker that you don't want. So by strategically placing a specific length and angle to the lead wires, we're able to maximize the excursion potential without the lead wires compromising any performance, creating any noise. And this is a cool picture here from our W3V3 assembly. Those little metal, channels, if you will, are machined by our machine shop, as with all of the other cool trays and jigs and stuff that we need for our production. We have this amazing machine shop, and you think we put out all these cool prototypes, which we do, but 95% of what they do, it's stuff like that. It's support, tools, trays, all the stuff our production team needs to build our products. But by using those jigs, we have that same consistent distance and angle to the lead wires every single time. And this really is, in my opinion, the right way to go. I get asked all the time, well, why not, weave the lead wires into the spider or, other ways. And, when you integrate them into the spider, again, they're not as flexible as the material of the spider. So now we have a spider that doesn't have a uniform consistency all the way around. It's going to be stiffer where the lead wires are, and they're not going to be as flexible. So by managing it this way, we can make sure we maximize the excursion. We're not compromising the suspension at all and adding any unwanted noises or potential, failures to the system. And again, this is found on all of our subwoofers other than the TW5 due to its, kind of radical 7-inch voice coil, and the W0s where they're strategically looped through the spider and not actually woven in.
Right. So interesting things about it is, I see this image, and, the three of us, Kevin, Rob, and I were talking about this a bit earlier. We see this, and from our eyes, this looks obvious to us. This is, of course, the way you'd want to do it. A nice controlled arc with a specific length for each lead wire. And this was revolutionary when we started doing stuff like this, because the normal way a speaker would go together is that the spider, the yellowish thing that's in the middle there, and the voice coil that hangs in it, that's usually glued into the frame of the speaker as one piece. Then the cone is glued into place. And what you have to do is you have to reach in between the magnet and the frame of the speaker, reach in and pull the lead wire and connect it to the terminal. So you're working within this tiny space, trying to get the wire, trying to determine its proper length, and then making a secure connection to whatever the terminal is, like, a nice spring terminal, something like that. So it's very difficult to make sure you're getting the right length, and very, very difficult to make sure you're getting the right arc on it. And all the issues that Rob brought up in terms of like the jump roping and the tension and all that is absolutely valid. And this, we look at this as like, of course, this is the right way to do it. How else could you do it? Well, how else you did it was the hard way. You reached into the frame. Now, of course, if you're dealing with an 18-inch speaker, you could probably get a small hand in there, but 6.5, 8-inch, 10-inch, good luck. It's not going to happen. You're going to wind up with a compromised lead wire system in most cases. So this development here, and one of the struggles I have with this, guys, is it's really awkward that most of the technology that we build into our product, it doesn't look great on packaging, to be honest with you. It's all about how we build a speaker and all the things that make the speaker more reliable and perform better. That's on the inside. It's not something all of you get a chance to see. So like the P-VAC, you can see that on the back of the speaker. The elevator frame, you can see that. But all this other stuff, it's embedded in part of our assembly process, part of what keeps our speakers more reliable and performing better. Ultimately, that's what you're after, but it's not as exciting as other technologies. You know what I mean? So this one, you can see it, but to really appreciate it, you got to remember how hard it would be if we didn't have access to a system that you see here. Now, Rob's going to talk about some other technology that's shown in this image that'll give you a clearer understanding of how the assembly is the key part of all of this that allows for these other technologies to be a part of it. So sorry, Rob, I thought that might be helpful.
No, that's perfect. And as you mentioned, we're going to talk about a couple more technologies, and we're going to see this image a couple of more times because this is the 4 patented technologies I was talking about earlier that's found in a W3V3 or W1V3 speaker. The next one is the VRC, or vented reinforcement collar. And I'd say the #1 failure point on a speaker is the key junction where the coil former, the spider, and the cone all come together. And typically you have a former, and it's very carefully glued to the cone. It's not the most robust assembly. When the VRC was developed, as you see, you'll see in the picture in a second, it really gave us a very solid assembly to mount the voice coil former to mount the spider to, and to also mount the cone to. And we'll talk about FCAM in a minute, but that's another technology that's integrated into the VRC for the attachment of the cone. This also provides a very heavy duty point of entry for the lead wires to, again, take stress and strain off of the lead wire management system. And when we look at this image again here, you can see how that is a lot more solid, a lot more mass to attach to improve reliability under high excursion than just gluing a former to a polypropylene or aluminum cone, whatever material you're using. But really, we've created a junction for everything to attach to and remove strain from a single point instead of kind of sharing it throughout the collar itself. On the inside, you'll also may have noticed on that line art image, but there's slots around the inside. That's, again, a cooling circuit that helps move air on the inner portion of the voice coil former. So it's not just for an improved key attachment point, but it also acts as a cooling circuit as well to help work with elevated frame cooling, again, to cool the inside and outside portions of the coil and coil former. Oh, wow. I was waiting for Steve to chime in there.
If you want, I'll add. So what Rob was describing is actually really good. I wish I had my parts with me, but if you look at the spider material, that's basically cloth. It's relatively thin. And the normal way that would get bonded to the base of the cone and to the side of the voice coil former would be with a tiny bead of glue that would go around that edge. And that glue, believe it or not, as many things are, it's going to be heat sensitive. Of course, it's stress sensitive too. If you pulled on it, it could break it. But if it gets hot, there's a chance that it could be compromised and those glues could break down. So what the VRC did, so the reinforcement part of vented reinforcement collar, allowed for a much larger contact area for the adhesives to bond between the spider and the collar itself. And on the inside of the collar, the VRC, is where the voice coil former would connect. And that would have a nice, 1/4 of an inch span of adhesive that would cover that. So you have a much larger contact area for the adhesive. Rob will talk about FCAM in a moment. That's kind of where the arrow is pointing in the tray in your image there. And the vented part are airflow holes that are terminating just above where the voice coil would be. So yeah, so perfect. If you look on the inside edge of that VRC, you'll see those oval-shaped cutouts. Those holes are right above where the voice coil itself would be. So when the dust cap is put on and the speaker moves, that the air that's inside there is going to blow through those holes right onto the top part of the voice coil. It's a question on Facebook asking about, is that why a lot of coils burn on the top? Yes. VRC sought to remove a lot of those failures to prevent that from actually happening. It was a really cool technology that had a really big impact on the reliability of our product. Now, the level of technology that's shown in this, the VRC and in this image, that's at the highest level. This was first introduced at our entry-level product. And at first the thought was like, why would you do this at an entry-level product? Shouldn't the tech belong at the highest level? Well, the answer to that is not always, because here it was a reliability thing. And typically an aggressive customer is going to be more abusive on a less expensive product than they would be on something maybe they paid a little bit more on. So we actually saw a whole lot more failures at the lower end of the price point that we did at the higher end of the price point. So we wanted to address that. And the VRC technology, first patent was 5734734. Yes, I have it memorized. But it was such a significant part of who we were as a company that it, again, that type of cooling circuit mentality and making the speaker more reliable, that became endemic to who we are as a company. And it stays that way to this day. And just for the record, yes, we do dissect product that comes back under warranty. We cut it apart, we document the failure modes, and we feed that information back to engineering so that they can continue to develop techniques like this to help prevent those failures from happening in the future. We're not encouraging you to try to break the product, but know that when you do, we're going to try to find a way to stop you from doing that. So no challenges there, please.
One other technology found in this image is our insert molded subassembly. And again, a very neat way to improve the integrity of the spider and where it would normally join to the frame. Steve kind of talked about, and we discussed with the VRC, that got rid of essentially just gluing three pieces together. And our insert molded subassembly does the same thing with the outer edge of the spider. Instead of just gluing the spider to the top of the basket where we only have one side of it being in contact with adhesive, the bottom side, on the insert molded subassembly, it's actually sandwiched into the assembly itself. So we have an adhesive grip on the top and bottom, which relieves a ton of strain off the spider. Again, very important when we're asking for a lot of excursion. So this has improved that reliability aspect, but it also does a really neat job of integrating the lead wires. If you look in this, if you look closely in the image here, I don't know if you guys can see my cursor right here, but where her thumbs are and where the speaker terminals are, you can see how the wires come out and then are integrated into channels in that insert molded subassembly. And then again, out of a strain relief for the engineered lead wires that then feed into the VRC right there. So again, it's not just about the improving the reliability of the spider, but again, it helps with the management of the lead wire technology and assembly as well. And again, all of the stuff is we're capable of doing because we do it ourselves. This is all built in Florida. And, a lot of important part of our production process is pre-assembly, being able to pre-assemble these pieces so we can then drop them into the speaker on the line is one way we're able to, be as efficient as we are, but also make sure we're not losing any quality because we're trying to rush certain steps to get it down the assembly line. So we have dedicated pre-assemble areas for some of our key components. And again, it helps with efficiency, but it also makes sure it's being done and assembled the right way with no compromises or any issues like that.
Three things I'd like to add, Rob, if I could. One's a point of clarity. With the tray itself, the outer diameter of the spider isn't actually glued in place. It's literally molded together with the plastic. So it's not an adhesive bond. It's all one part after it's been formed. That's a huge advantage. We don't have to rely on an adhesive bond. What does get glued is the tray gets glued into the frame of the speaker. So there technically is an adhesive bond there. But if you look at where her fingers are, that thumb that Rob pointed out, if you look carefully in the center, you'll see that it's like a little pattern of where a nut would go. There's actually a bolt that goes into the frame of the speaker that gets bonded together, not just by adhesive, but it's bolted to the frame. So you don't have to worry about that adhesive ever coming off because it's held in place with a bolt, literally. And it's really awesome. everything that Rob shared about the positional issues is a huge one as well. In a typical speaker, when you drop it in and you try to align the voice coil lead wires, you have to try to make sure it's lined up perfectly with wherever that terminal is going to be. If it's off a little bit, one lead wire is going to be longer than the other one. And that's going to cause an inconsistency in performance and could limit the behavior. It can't be rotated differently. There's a hole in the frame where the terminals drop through and the bolt that holds it in place. So it's always going to be lined up perfectly on the frame, and the lead wires are always perfectly lined up with the voice coil. Very subtle distinctions, but huge when it comes to being able to reproduce at volume a high quality, very reliable product with great performance. All of that was by design. I remember, and Mark, you may not remember this, but when I was doing some trainings, we would go to the UK. That's where Mark is from. He's watching here on WebEx. And they would give us a horrible time about the look of our old terminals. Now, most of you probably don't remember, but back in the early days, we had really basic terminals on our speakers, and we would get killed in the press. Yeah, it's a great speaker, but the terminals are horrible. And we would always come back and we'd feed that back to the engineers. And we'd say, can we please do something about the darn terminals? Everyone's giving us crap about the terminals. And Lucio and his team kept saying, don't worry, we're working on it. We're working on it. It's like, how hard can it be to just put some spring terminals on these speakers and make everybody happy? It's like, when I come out with a solution, it's not just going to be cosmetic. It's going to be mechanical in nature. This is what they were working on. This was the solution to the bad terminal. We not only just improved the terminals, we improved the way speakers are built. And that's the way we do things. So sometimes it takes us a little bit longer, but there's always a reason for that delay. There's always a reason for it, because we usually throw in a whole bunch of technology at it. Sorry, Rob.
Michelle, here's your proposal, and guess what I put in it?
So also available that you can see in this picture is our FCAM technology. In this image here, it's part of the VRC, and you can kind of see right around here, we have this kind of channel on the VRC. And on a normal non-VRC speaker, at the top of the coil former, instead of just gluing the coil former, spider and cone to one piece, we actually have a channel, if you will, along the outer edge of the former. And this allows us to drop the cone in, hence the name floating cone attach method. The benefit of using FCAM on our subwoofers is you always have the perfect geometry of the cone. Being we're dropping it into the cone into a purpose-built channel, it's always going to align properly. So you don't have to worry about any contortions or any added stress to the speaker. Changing the geometry of the surround due to the cone not being seated properly. So again, this is a method that allows us to build a better speaker, improve the efficiency on how we assemble, but it also maintains linearity as the speaker is moving by having a dedicated channel to drop into. And since it's a dedicated channel filled with adhesive, we have a higher bond as well. Instead of just slapping glue around two pieces, this is sitting in a channel. And again, that helps relieve stress in that key attachment point, especially when it's under a lot of force and movement. So again, you'll find this on W7, W6V3, W3, and W1V3 products. Essentially the products, full-size woofers that we build here in the United States. And again, a very different way to attach a cone to that very high stress area. And again, you can see it in the image here.
All right, go back to that cutaway, because there's some really good stuff I wanted to share, if you don't mind, Rob.
Nope.
Okay, so in the green circle up at the top, that's FCAM, the floating cone attachment that Rob just described. I'm going to come back to that in a moment, but I want to point to just on the inside of it, you'll see there's a contact area where the voice coil is actually making connection. That contact area normally would just be the thickness of a bead of glue, but we have a very large contact area there, as well as slightly below that, you'll see where there's a contact area just above the spider. And that contact area there is also significant. Now, if you look carefully, the spider itself cuts up underneath that reinforcement collar down there. And that's, again, a much larger contact area for that adhesive to make it more reliable. So you can see all the benefits of those larger contact areas in terms of reliability and build practices. Now, real quick on that floating cone attachment method, in a traditional speaker, one of the last adhesive bonds that is made is where the surround, if you look at the upper corners of the image that's on your screen now, the surround is making a contact on the top part of the frame. And since this is a visible thing that you would see from the field, you want to make sure that that looks really, really pretty on the outside. But unfortunately, what normally happens is to make it fit into the frame, they wind up stretching it from one side to the other because it's what's known as stacking tolerances. And what that means is each part is going to have a window of sizing that's acceptable. So you might have a 5% or 2% tolerance. But let's just say everything is 2% too big or 2% too small. You wind up with this stacking of tolerances as you build from the back of the speaker and you start going to the top. You could be 12% off at the top of the speaker. You have to make that error up somewhere, and the surround was often used to make up the error. So they would tug the surround, but it wasn't consistent all the way around. So they tug it on one side, and the surround wouldn't be that nice even arc. It would be flatter on one side, and the other side would be kind of scrunched up and be taller. And it doesn't look that good. That's one thing that's bad. But what's really bad is when that speaker starts to move, the side that's been stretched doesn't have as much excursion capability. There's less material there. But the other side has lots of capability. So what winds up happening is the speaker rocks, and the voice coil inside the back part of the speaker then has the ability to rock up against it, causing a rubbing way earlier than it should ever get into contact with anything because of the inconsistency in the way the surround is put in place. What floating cone allows us to do is we just drop the cone in with the surround on the plateau and we glue it where it's comfortable, no stretching necessary. The base of the cone sits into that tray that's filled with a slow curing adhesive. So literally the cone drops into that channel and it floats into the center point. So there is no stretching. Wherever it is, now you have a perfect piston, even at the highest levels, because there is no compromise on the parts. This technology, and that's why I wanted to jump in, this technology is so critical to high excursion designs, but it's so hard to explain without imagery like what Rob has on the screen for us here. That tray allows us to not compromise the excursion capability by compromising that surround. And it's a massive improvement to the way we used to have to build speakers. And again, it's hard because building is not really what's exciting. It's the performance that is. But a lot of the performance is hindered by the way we used to have to build. So all of these changes, all of this engineering solutions were all about the way we could be better at building the product so that you would get better performing product with higher reliability as well. So I'll try to stop now, Rob. I know you have a few slides left. So
yeah, only 2 technologies to go, but they're kind of big ones. The first one being the concentric tube suspension, which Steve alluded to earlier. This is the key element to designing a shallow, thin woofer without compromising performance in both output and low frequency response. And, as Steve was talking about earlier, this was an idea of Lucio's way before the W7. He had this idea, back in probably the early 90s, if not earlier, that if he could suspend the suspension around a motor, he could make a thin woofer without the compromise. And I remember in the early 2000s when shallow woofers started to come out, they were typically a shrunken down speaker. You had a smaller frame, which meant you had a smaller motor, which meant you had a smaller, stiffer suspension. So yeah, it would play bass, but it didn't hit as low or as hard or have the output that a full-size sub would, because we've shrunken everything down and really limited the potential. With the concentric tube, and by being able to essentially put the motor up inside of the suspension, you can have that low profile footprint without compromising excursion capabilities, because you have a full suspension and a full-size motor, which means we can run more power through it. We can get a larger coil in it. And if you look carefully in this picture, between the yellow spider and the rubber surround, you'll see that plastic kind of tray. You'll see the plastic arms that are going around. There's the concentric tube. And when Lucio first drew this up, this is what Steve was talking about, he went to an plastic injection molding plant, says, here's this cool design I have. I want you to build this. They said, not a problem. They come back months later. That is way too intricate of a design. You can't injection mold a piece like that. So we went to their competitors. They said they could not do this. Can you do it? Of course they said yes, because they wanted our business. And they came back. That's too crazy of a design. You can't mold a piece like that. So Lucio actually stopped designing speakers and all of that stuff and literally designed the mold so he could pay these guys to build the piece for him. So here's the mold. Now, can you make this for me? Because I did all the hard work for you. And that's really why the TW5 didn't come out until 2008, because no one could build the concentric tube until Lucio made the mold for it. And really, it did revolutionize the thin woofer game by being able to have that low profile, but have the full size woofer performance. On the TW1 and TW3 models, it's a little different than what the TW5 had, where we had that big voice coil on the outside of the motor. TW3 and TW1s use a more traditional motor and voice coil. But again, I love this image here, because when you get to the right and you kind of almost like a cutaway, you can actually kind of see right here the edges of the concentric tube and how the spider is attached to it, and how that allows the woofer to move on the outer edge of the motor. So again, we have that full excursion capability, but we have significantly less depth. And this is a really cool image to compare. If you look at
really
A, it's the bottom of the mounting flange to where the spider is, and then B is the spider to the bottom of the frame, and then C is your motor depth. But if you look at the TW3, C is up inside. So now we're only dealing with A and B. The distance from the top of the frame to the spider, and the spider to the bottom of the frame, which by not having that motor attached to the back of it really does allow that amazing performance that you find in the TW line of products, from TW5 V2 all the way down to the TW1 series.
Don't change the slide yet. This is a great opportunity to really tie a whole bunch of things together. On the left-hand side of your image there, you'll see where the spider and the cone and the voice coil normally would meet. And you see that's a very tight area. There's not a lot of room for adhesive for each one of those bonds. So that's one of the things that we've tried to correct with some of the other technologies. And everything Rob just talked about on the concentric tube is really evident here, because normally the spider is attached very up high on the coil. It's at the top of the coil. If you look here, it's not even attached to the coil. The coil's in the center of the speaker, and the plastic that forms the concentric tube is what's dropping down, creating a plateau for the spider to attach to. That was the tricky part. With the TW5, we put the whole motor up inside the voice coil. This one, we used a more traditional geometry where the coil's in the center of it, and we just drop the plateaus to the outside of the frame, of the concentric tube. But getting rid of the C dimension was what was critical. We still have the same motor type structure. It's just now tucked up inside underneath the tray of the concentric tube. It's actually quite brilliant. This technology, the original one on the TW5 that Rob already talked about, that predates even the VRC technology, which is the first patent that went to market. But this one predated it. And just for a point of clarity, today, injection molding has come so far that these parts would have been easy. But 25 years ago, when Lucio and his team were developing these ideas, it was not to that point yet. So he literally was pushing the envelope in terms of what could be done with injection molding. Today, if he had come up with this today, it would have been a lot easier. And I bet he's wishing he waited, but there's way too much that has come a long way from then. But that it's one of those things you have to remember. A lot of these ideas were done at a time where none of this could be created. We literally pushed the envelope on all of it.
Yeah, great point. The last one is the tabular frame design, again, found on our thin woofer family of products. What's unique about tabular is it allows us to really I look at kind of similar to what we did with the overroll surround. It allows us to maximize the space we have to work with. So by using the tabular design, instead of having a wide flange all the way around, we can make essentially a larger piston area and really mount with the tabs that come off of it instead. So the benefits to that is it really makes it a lot easier to get the drivers closer together. And this is one of the really big benefits with the TW1 series. But if you look at a pair of normal speakers, we've got a space, especially if you have them close to one another. But when you look at the benefits of tabular design, here's the TW1s, for example, you can see the space that has been saved. And that might not look like a lot, but that 1/2 inch, 3/4 inch, 1 inch, depending on how wide the flange is on a comparable speaker, that could very well be the difference between getting 2 drivers or 1 driver. Could be the difference between getting a larger diameter speaker where you would normally have to do a smaller speaker. So this is a great way to make sure we're not compromising any of the piston area, and also taking as much advantage of the space as you can. I forgot where I saw it, but I was looking at the 13W TW5V2. The diameter of the frame is only about a ½ inch larger than a normal 12, but it has a considerably larger cone area, piston area to work with. So it means it's going to move more air. It's going to be louder. You're going to get that better output potential. So, I get asked all the time, why did you guys do that? I can't put it in a normal prefab box. Well, there's a reason for it. It's, again, like everything we do, it's purpose built to a specific application. And when you're trying to get as much base as you can in a space where there's not a lot of space, tabbier design is a great way to either move larger or get multiple woofers closer together without wasting a bunch of space that a typical speaker frame may have. So
Rob, you brought up the key word, so you knew I was going to jump in. It's purpose built.
Yep.
We designed these products for a specific reason, and you'll notice that the tab ear construction was only used on the TW1, the TW3, and the TW5. There's something else that those three woofers all have in common. First of all, they're thin, right, which means they're intended for shallow mounting applications, but their box volume requirements were correspondingly small. So this is all about saving space. So every little bit that we could find that we can make things more compact and more dense to get more performance from the smaller footprint, that's what we were looking for. Tab ear, exactly what Rob was just describing. If we went with a standard frame, even though the box volume got smaller, you were still forced into larger volumes, larger geometric areas, which brings up the issue of volume. Rob mentioned prefab boxes. Using any of these drivers in a normal prefab box, the box volume is way too big anyway. So that should not even be a consideration. The box volume requirements for the TW1, TW3, and TW5 are unlike any other of the drivers that we would normally offer. So the prefab box shouldn't even be part of the conversation. Yes, we do have some boxes, but you can also build one from our owner's manual. It's almost exactly the same as what we would build for you. One thing that I remember doing at one of the trainings was I brought the cardboard boxes that we would ship these in. And I basically said, okay, if you made this out of MDF, you have your box. And it was true. The box volume of the cardboard that we shipped it in was about the same box volume that was required for the proper sealed enclosure for the TW1s for sure. But the tab ear allows you to get two 10-inch speakers into the area where normally maybe only one might fit, both in terms of volume and the physical space for the geometry of those drivers. Again, Rob, you said it best. It was purpose built. We know the application, we know what we were looking for, and that's what we designed around. So all these engineering efforts go into practice for that. So. Wow, we went long.
That's all your interruptions.
I know. I looked at the clock. I'm like, darn, this is not Rob. This is all on me.
This one, though, I appreciate it because, since you're the old man at the company, you were around when a lot of this stuff was being developed. So I know you got some cool stories and insight that none of us currently get to see or know about because we weren't there when it happened. So.
You just called me old in front of all these people. I'm really offended by this. I guess I deserve it in a way. But yeah, it was exciting, working at JL Audio when the engineering team was laying the foundation for a lot of this stuff. And I remember we'll have to resurrect it when we do the W3 training, the Fireball, the Fireball Be Afraid logo that we came out with many, many years ago. That was awesome. I think, Rob, do you have that on your wall? You might. I don't know. Yeah, you do. The behind Rob's head, there's a Fireball with the JL logo right behind his head. So that was our ad, Be Afraid. And that was a kind of a precursor to the W3, first real version of the W3 coming out, because a lot of that technology was starting to be brought into these products for the first time. And it was truly groundbreaking, like a big fireball would do. It was pretty awesome being around when all this stuff was being thought of and brought to market, and watching us set up all the production lines and figuring out the fixturing that we need to build, and hence the investment that Rob mentioned in our machine shop, and seeing really the formation of the company that everyone that's watching right now has known to come and hopefully love. So yeah, it was cool, and I'm glad I can share some of that insight. I'd love to take all the credit for it because it's really cool stuff, but I was really more of a fly on the wall for a lot of that stuff.
Yeah.
So what questions did we not cover, Kevin? I know that there's a couple that you had commented on that maybe we cover at the end.
Yeah, there was one I wanted to cover, but I do want to add I didn't want to jump in while, you guys were jumping in on each other there. So.
Guilty.
But one of the things I did want to add, especially when we're talking about like the concentric tube and some of these other technologies, that when you look at a speaker, it is only as good as the weakest part that is involved with it. You can only get as much excursion as the lesser part will allow it. So if the voice coil can't be long enough because it's been shrunk down to make a fitment, or the motor's been shrunk down to be able to make a fitment in there, you can put the biggest surround on there and the biggest spider on there, but it's irrelevant. It's only going to move as good as what the weakest part is on there. And that's why we have so many of these cool different technologies to go in and really just get the best performance, and they really all work and intertwine very, very well with one another.
Excellent point, Kevin. Good. I'm glad you brought that up.
So baseball. The only one that I really wanted to bring up was one of the guys asked about cooling, and if vented enclosures actually offer better cooling than a sealed enclosure. I thought that was a pretty cool, interesting question. It's
a cool question.
I had to jump on the bandwagon with you guys and the bad cool jokes. So yeah, that was one I wanted to bring up in there.
So to some degree, yeah, porta boxes are going to be beneficial in that regard. But I would like to add that if you're relying on that as a way of being able to beat the crap out of your speaker, it's a really bad way of going about it. So yeah, well, I'm tired of burning up speakers. I'll just port the box. No, don't do that. Ported box versus sealed box or band pass, those equations should all be balanced upon the performance expectation and the space available for whatever you're trying to accomplish. As a side benefit, porta boxes can offer some improvement in terms of the air exchange from the ambient temperature around the frame of the speaker. The other thing you could do, although it may not look as good, is if you're worried about that, mount the speaker in reverse. So you have the motor on the outside, so you have plenty of air blowing across it. At that point, you have to make sure that your driver has been designed to allow the airflow through the frame to not be noisy. The chuffing noise can be more evident on the back side of the speaker than it would be on the front. So if you're really worried about that kind of airflow, you could literally just mount the speaker the opposite way. A little tricky to do with a W7, I might add, but it can be done. So yes, the simple answer is yes, a vented enclosure can offer some cooling advantages, but I would advise caution of using that as a way to try to keep the speaker cool. It's a side benefit, not the benefit.
And if you're dealing with a speaker that doesn't have great cooling capabilities and it's not able to get the air out of the voice coil and move that air in and out, you can have an infinite baffle application and it's still not going to help you out. The speaker and the technologies that are in there really need to move that air in and out quickly to make that voice coil cool down. And like I said, you could have an infinite baffle in Alaska and you're still going to heat that voice coil up if the technologies of the subwoofer aren't there.
So people making fun of my frequent interruptions of Rob. Sorry. Hey, I'm sorry. When it comes to subwoofers, again, watching them do all this stuff, I get really jazzed. It was so cool seeing them, because they all got giddy about it too. Whenever they came up with something that worked, we call it Frankenstein it. They would Frankenstein up a mock version of it and test all of it, and to see it all working and then being able to produce it and be able to build basically everything from there on this new technology. This is really cool. It's, no pun intended, but it was really neat to watch all of that take place. So it's hard to hide my enthusiasm. And I wish Kevin and Rob were with me all along. I'd been better off a long time ago. But since they weren't around for that, that's why I wanted to jump in and share some of those early stories. So hopefully it wasn't too invasive.
Well, that's always good information.
Thanks.
It gives me enough. You interrupted me enough. I was able to drink a full water bottle while you were talking.
That was the other part of the goal.
But the problem is that you make it long enough that now he has to use the restroom.
Yeah.
So one thing that's kind of interesting, Kevin and Rob, as we've done a lot of these online sessions, we've often asked for feedback of what other things that people would like to hear about. And almost every single one of them, someone brings up the W7. And we were kind of kidding around. I'm really glad we didn't put it out there about, we were going to take a shot every time someone asked about a W7. We'd be inebriated. It'd be a terrible situation. But that's why I was so excited to be able to do a subwoofer technology one, because as you saw from the beginning part of the presentation, W7 is a tour de force when it comes to technology. It laid the groundwork for almost everything. So a question was, how much of this has gotten onto the 13TW5? Pretty much all of it. Maybe not each specific technology, but the thought pattern that went into designing those products. All of these ideas have been, foundational for all of the technologies, whether we use it or not. The cooling circuits, we have all different types of cooling circuits on all the different designs. The application specific thing that Rob brought up, all of that it's all integrated, very, very tightly integrated. One thing that our company is very fortunate about is we have an incredibly low turnover throughout the entire facility, from our production team all the way through to upper management, our engineering team, our support teams. We've all worked together for many, many years, and the engineering team is one of the strongest nucleuses of the company that we have. There's a huge group of people that know each other's thoughts. They know exactly what to expect from each other, and as a result, they can get really excited about developing new technologies and bringing them out. They also work really closely with the production team that has now come to be familiar with the style of engineering that we do. And they're just getting better with every iteration. And we keep adding new production lines and improvements in the way we build things and design things. And although we didn't get into it today, there's certain aspects of the way we build product that has filtered into our marine speakers, including the subwoofers, which do share some of these technologies, that is now part of the way we build other products. And it's really kind of neat. It's it's a normal engineering team might say, okay, we're going to design this product and we're going to bring that to market. And then we're going to design this product and bring that to market. Creative ones might say, these are the 3 products or whatever that we're going to work on and bring to market. Our engineering team is very, very different from that. And maybe this explains kind of the way JL Audio thinks is we develop technologies. And we come up with all these design ideas and technologies of way to solve problems that we've identified, either reliability or performance or hiccups in production that make it hard to produce a quality product. We'll identify those problems, and engineering by definition is solving problems. So that's what our engineers will do. They'll find ways of solving the problems, and they'll take the technology and kind of put it on a shelf. And then we'll say, okay, what do we do with it? Well, let's use this technology and that technology and put those together and come out with this product. So very rarely, everyone asks, what are you guys working on? We're working on technology. And when we get enough technology that we can come up with a new design and put all these technologies in place, you'll see some new product from us. And when you do, it's special. It's always special. It always has been and always will be. When JL Audio says, we've got a new woofer, get ready, because there's something special about it. You saw it with the W7, you saw it with the W6 V3, the TW series, the 5, the 3s, the 1s, each one brought something new to the marketplace. And that's what we do. We develop technologies and bring them to market as a suite of products. And I think that's awesome. I think that's the right way. Not the fast way, but I think it's the right way. 8W7 Hobach, Steve Moss. If it was one guy that gave me enough crap about our terminals, I think it was Steve Moss over in the UK. So yes, he remembers because him and I have been going at it for a long, long time. 8W7 and an HO enclosure, I think that'd be phenomenal. The problem is it'd be expensive. The 8W7, this is inside pool here, so I apologize for kind of spilling the beans, but when we develop our product line, it's not common for us to say what the price points are going to be. So what we'll normally say is, okay, well, the 12 should be around this amount, and the 10 should be a little bit less than that, and the 8 should be a little bit less than that. But that's not how the economy of it works, certainly not on the W7s. The reason for that is the 10s and 12s tend to sell in higher volume. They're more common sizes, they're more popular sizes, especially for a high-performance driver. People don't think of 8s as a high-performance driver. They've clearly not heard the 8W7, Steve. You know this. You have. So when it comes to forecasting and purchases of the parts for an 8W7, it turns out that the cost of the parts of an 8W7, when you add them all up, is about the same as the cost of the parts for a 10W7. How would you feel if we charged the same amount for the 8 and the 10? I can hear you now. I don't have to wait for Facebook to catch up. You wouldn't like it one bit. As a result, the 8W7 is not a profit maker for JL Audio at all. And the number of enclosures we might sell for an HO version probably would be even smaller. So that's probably why we don't do a whole lot with HO on 8W7. I like the 10-inch version, personally. I think that's pretty badass, technical term. Steve has cash waving. Yeah, but you got that funny, weird, plasticky money. I need greenbacks, baby.
What's the HO box you had in your car for a while, Steve?
Let me think which one. Oh, actually, my favorite HO enclosure for many, many reasons. Not just, it was a great performer, although I could argue there are other ones that are better performers, but it was the 10W3 HO. I can't even remember if we're still offering that, but it had an angled back, so it matched up with the angle of most seats in a sedan, and it had the bar grills across the front with a oval type aperture, and it had a rear firing sub with the HO venting terminating in the front behind the main baffle. It was a beautiful looking enclosure, looked nothing like anything else that was available at the time, and it had phenomenal performance at a price point that an average customer could at least strive for, if not easily afford. And what I loved about it was it offered a higher level of performance than anyone would expect from an enclosure at that price point. And because it wasn't really expensive, in my mind, I would design systems around using one of those with a multi-channel amplifier driving a pair of coaxials up front all day long. And that would be a hammer system that would last, would be reliable and perform really well. I can't remember what I had in my car that would make you ask though, Kevin.
You had a 8W7 in a box that Eric designed.
That was a sealed enclosure that Eric designed. And the funny thing about it is, oh God, I'm getting giddy again. Being the old guy, I had an opportunity of hearing all of the different drivers as they were developing them, because that's what we do. We listen to them. But the guys that came on later, they didn't have that opportunity. And it's not easy for us to just grab a woofer, throw it in a box, right? Because we got a job to do. We can't just do that. But many of you probably know Eric Cole from our technical support department. And Eric does this. That's what he does. He'll just build boxes just for the fun of it. And he asked if it'd be okay for him to build a box for a W7 8 because he'd never heard one. You never heard an 8W7? Oh my God, you got to do it. So you build a box, I'll put it in my car, you get to listen to it. So sure enough. Well, because if you know Eric, he's got a Civic, and it just wouldn't work well in a Civic because of the way he did his installation. He's got a really specific thing going. So an 8W7 wasn't in the cards for him. But here's an opportunity that I could get an 8W7 in my car, and he gets a chance to hear a speaker that he never heard before. And I've said this before, and I'm going to say it again, and I want you to make note of this, everyone, if you haven't heard me say this before, that Lucio and his engineering team built a reputation of making some pretty awesome subwoofers. Our company's history has been built on the backbone of our subwoofer technology and performance. We've expanded that with our engineering efforts in terms of electronics, both amplifiers and DSP. But when it comes to subwoofers and it comes to driver design, there is no one on the planet, in this man's opinion, there's no one on the planet that's better at it than JL Audio and Lucio Proni specifically. He is so good at this. It's frightening. All the technologies came from his brain and executed by his team. And let me tell you this, without any hesitation, smaller drivers are his strong point. So what you've seen from 10s and 12s that gets everybody excited, when you start getting into the 8s or even the 6W3, I don't know if we offer that anymore, these are incredible drivers. Nothing like it in their class, anywhere, at any price point. That 8W7 is amazing. The 8W3 is amazing. The 6W3 was amazing. When he gets into those smaller designs, there's a magic that he can put into a driver unlike anything that we've done anywhere else. I get excited. I get goosebumps. So yeah, if you have a chance for an 8W7, listen to it. It's got a different characteristics, but it's phenomenal sound quality. And if you're like Dan Barzone over in our Phoenix office, put 4 of them in the back end of a caddy with a couple of 1,000 watts. Oh yeah, you got a lot of performance on top of it too. So yeah, I love our smaller driver designs. So all the Marine speakers, this is what I'm talking about. Those smaller driver designs, that 880. There's magic in there, guys. Give them a listen. If you haven't, give them a listen. They are truly remarkable drivers.
That I have a 6W3. I see Adam on WebEx is mentioning them too. I have a 6W3 and a 0.3 cubic foot ported enclosure. And that thing hauls. I mean, it brings the mail home. It's great.
No doubt. There's a mentality about smaller drivers because for so long they were so limited in terms of performance. And Rob, you really touched on something pretty critical, that typically a low mounting depth or shallow mounted subwoofer is a normal subwoofer that just said, well, just make everything smaller so it fits. And by doing that, you really compromise the performance. The same is true of smaller diameter speakers, that very often they just make the diameter smaller and scale everything with it. It's not the right thing to do. The right thing to do is find a solution to the excursion problem, even at smaller scale, but be it a diameter or a mounting depth. And there's no free lunch with some of this stuff. There's either going to be a higher cost penalty, like you see on an 8W7, or a higher depth penalty, like you see on an 8W7, or you're going to have difficulty in terms of building it, which of course we hit with our own production. That's why we actually have all of our production lines. As Rob said, some of our manufacturing partners that we work with around the world, some of these technologies we hold near and dear to our heart, and we're not going to help build a production line outside because they may use it for other purposes. And all these highest level technology is often reserved for our in-house manufacturing. And it's not just for trade secrets, of course, there's a bit of that, but it's also because to set up all of those fixtures, there's an enormous cost associated with that if we wanted to do it overseas. It's just not, it's not feasible. It's a lot easier for us to do it in-house. We have the machine shop, we can build the parts and do all that ourselves. So we do. What else we got? Anything? Daniel just asked about a bandpass enclosure. He referred to it as a fourth order, and I have an issue with the term order in this case, but I'll let it slide. But a fourth order enclosure, for those that are not familiar with the way bandpasses work, is a combination of a sealed chamber behind the driver and a ported chamber in front of it. And the two chambers work together to alter and modify the performance of the driver to create the most common application is an increase in amplitude over a narrower band of frequencies, a band pass enclosure. It allows a certain band of frequencies to pass through, and you can alter how wide or narrow that is, or how loud or whatnot. And a fourth order is a typical sealed chamber and a ported chamber. This was probably the most common because it was a lot easier to get predictable results. Now, modeling software has come a long way as well, and we get a better job of predicting some of the performance of other bandpass enclosures. On an 8W7, I imagine that'd be kind of tricky. I think Eric Cole's your best friend on that. I think he's actually looked at this quite a bit. He's a W7 fanatic, so he's analyzed these things in terms of design, enclosure design, probably more than anyone else in tech. So if you want, maybe hit up Eric Cole at our tech department, and maybe he can come up with some designs for you. The issue I have with bandpasses, particularly on W7 drivers, is the alteration of the top end of the frequency response. Now, I get it. People like loud enclosures, but what's really special about a W7 is, W7s are not just loud speakers. Yes, they have lots of excursion and they have the ability of playing incredibly loud, but their detail and resolution is exceptional. It's unlike any other driver that I've ever heard. And by putting it in a filtered enclosure, like a fourth order or a bandpass enclosure, you're going to affect some of that top end response. And what I mean by the top end is obviously the low frequency is going to be very strong. It's a W7 after all. But the way it transitions to your mid-bass drivers, if you have a whole bunch of energy with a sharp roll-offs like a bandpass will typically have, that transition to the mid-bass, there's going to be a gap there, and I don't like that. If we stuck with a ported enclosure or a sealed enclosure, that transition can be really, really smooth and really detailed and accurate. And as a matter of fact, a lot of what we did with the design of W7, by the way, if you have to go, I get it. We've run way, way long. I saw Rob took a break. I can imagine why. And we will be doing a W7 training at some point in the not too distant future, and we'll get into this a bit more. But when we worked on the coil design for the W7s, some of the things that we did with the coil was to reduce something known as inductance. Now, inductance, you've probably heard this term before when it comes to like passive crossovers. There's an inductor. An inductor is a filter for high frequencies. Well, it's a coil of wire. Well, a voice coil is a coil of wire, so it has inductance too. And the bigger the coil, the more massive the coil is, the more that inductance is going to be a factor. And what inductance does is it filters off higher frequency response. So here you have a coil that's filtering off higher frequencies pretty naturally. And you've probably seen this if you've ever played a subwoofer without a low pass filter on it. It doesn't play high frequency very well anyway, and it has a lot to do with the inductance. But we worked really hard on the W7 to minimize the inductance so that it could transition better into mid-bass drivers, so that it would sound better when you blended it in with the system. So there's a lot of magic that you might lose by doing a filtered type enclosure like a bandpass enclosure that kind of blocks some of that natural roll-off that the W7 has that we work so hard on. We talked about terms to use with W7s 20 or so years ago of how we would want to promote the product. And clearly the output capability was second to none back then. And I contend that it's rivaled by very few, if any, in terms of true ultimate output. But the detail and resolution, the sound quality aspect of it, I don't think that's been matched yet. And that's a bold statement to make. So there's some really good product out there, but you take everything as a holistic approach to subwoofer design. I don't think anyone's hit all the same boxes that the W7 does. So we were calling it SQL kind of thing, right? Sound quality, but loud. It could play loud and low. And the first thing that Rob shared in terms of technology was the dynamic motor analysis. And that was a big part of that, that even at higher levels, we didn't compromise the integrity of the motor strength. It stayed consistent even at massive amounts of power. And even today, 1,000 watts into a single speaker is still a massive amount of power. I don't care what amplifier you're looking at. 1,000 watts into any speaker is a ton of power. And that could cause all kinds of misbehavior in terms of motor strength and certainly in terms of heat dissipation. There's all kinds of concerns that come in. And again, I'm biased. I do work for JL Audio and have for a long time, so I kind of feel a very strong allegiance to it. But I think you'd be hard-pressed to check all the same boxes that the W7 does. I don't think there's a product that doesn't. All right. You okay now, Rob?
Yes.
You ready for another hour and 20?
As I was typing, I was going to say, I'm going to keep Steve going here a little bit longer. And then you just got up and left.
Couldn't hold it anymore. Steve's interruptions were so many. All that water and it had to go.
I started in this business, and of course, subwoofers were king. Late '80s, early '90s. That's bass was all over the place, and sound quality was coming into its own, and a lot of cars were starting to sound better and better. So I learned in this business around some of the best there is in terms of subwoofer design. So I get jazzed up about subtech. So when you talk about it, you're going to get me going, and you see the result. Fantastic. If we didn't get to your question or anything, just fire a question over to our tech department. They'll do their best to get back to you, or you can contact Kevin, Rob, or myself. We do still ask that you share with us any feedback you have about ways that we can make these sessions better for you. One way would be for me not to interrupt as much, so we already know that one. The other things that we're looking for is what content you might want to see from us. What do you want to learn more about? Hopefully it's a JL Audio related topic, but if it's not, let us know what you want. Additionally, let us know what day of the week might be better for you than, we typically have been doing these Thursday afternoon thing. And we do it at 4 o'clock typically, mostly because we haven't heard any pushback or feedback otherwise. And I know Mark is hanging in there and it's getting late over there and he's still online. And I really appreciate that. And we do appreciate your attendance, and we want to give you the content you're looking for on the days and times that you're looking for as well. And we'll do our best to accommodate you. So on that note, I'm going to really seriously stop now, and I'll say goodnight, and I'll let Kevin and Rob say their farewells as well.
Thanks for joining, everyone, and look forward to seeing you guys when we start breaking down the individual subwoofers and how these technologies, we'll get more into how they apply to those specific family of drivers. So this is an exciting start to a good series of training. So thanks for attending.
Thanks, everyone. We'll see you next time.
Yep. Take care, everybody. Have a good night.